Morning.
Good morning, sir.
Tapos na klase, sir. Tapos na klase. Oo, hindi na ako danay. Can you guys see my screen?
Yes, sir. Kita, sir.
Ayan, so review muna natin yung module 4. So check your isa pa lang nakapasa. Glacial. Sige, so review natin yung mga proof nila, no? Maganda dito. And so I guess nagets yun naman yung step-by-step process dito. So dito tayo nag-start. In-evaluate natin using the Euler's theorem. So you can only use cosine theta. That is e raised to j theta plus e raised to negative j theta, no? Over 2. Pag sa sine naman, subtract natin. And then the sum of those cosine theta and j sine theta, or ito yung trigonometric complex natin, di ba? So that is the sum of those theorems. So kung titingnan natin dito, we use the notation natin. Ayan. So we use the trigonometric quadratic formula here for evaluation. And then for this case, pinactor out natin to. So paano ba nagganito? May nagtanong, sir, bakit nagganyan? So pinactor out natin yung yung ito. So that is 4 minus 4x squared, di ba? Pinactor out natin to, yung 4. So nilabas natin, you can have 1 minus x squared. Tama. Ayan. So, pinactor out natin tong loob. Then, with the use of radical rule, expand natin siya. So, yung kalalabasan nito, di ba ito siya, square root of 4 minus 4x squared. So, pinactor out natin. With the use of radical rule, pwede siya maging square root of 4 multiplied by square root of 1 minus x squared. Tama? So, we use here the radical rule. Then, in square root lang natin to. So, ito square root of 4 is 2. Diba? So, ito siya. Multiplied by yung natira, square root of 1 minus x squared. So, review nyo yung basic. Although kahapon, may consultation with regards to the TOS of the board exam, no? Mawawala na sa board exam yung algebra, trigonometry, geometry. So, yung covered na would be from calculus up to advanced algebra or advanced math. Yan. So, siyempre, na-cover nyo naman yung basic math ng algebra, trigo, geometry. So, hindi na siya lalabas sa board exam this coming October. Pero sa April yung last na board exam wherein kasama pa yung algebra, yung basic math. Ayan. So, yun lang. May nag-question pa with regards dito. So, the same with this one, no? So, factor out din dito. Okay, so, factor out then radical rule. So, review niyo yung basic math natin. Ayan. So, ano pa yung naging concern? Dito sa trigonometry. Sa example, no? Example dito. Okay, so familiarize na lang the functions, hyperbolic functions. Familiarize the hyperbolic functions of complex numbers. Inverse din tayo dyan. Then yung identities. So, yung identities yung very important. This one. So, this is very important. Ito, basta sa di ba? Sa exercises ninyo. Okay, so, let's take a look sa mga examples. Naka-record ba tayo? Okay, naka-record. Okay, so here now we apply the trigonometric identities. Then the addition formulas for this case, no? So this is basically cosine of your first term, second term, that is 0.570. So this is your x. This is your x and this is your y. So with the use of trigonometric identities, you will have cosine x, cosine y minus sine x, sine y. And then for the addition formula, so combine natin yung buong cosine. So dito sa kabila, multiply lang natin. So that is cosine of 0.573, cosine j. So here, that is 0. This is an complex form. So imaginary 0.783. Ayan, tama. So eto, pwede na natin ito ma-direct, di ba? So we just need to convert it to degrees para makuha natin yung value. But dito, sa j, sa cosine j 0.783, so we need to use the relation dito sa relations between hyperbolic and trigonometric functions. Ito yung gagamitin natin. So we have cosine jx, di ba? So that is equivalent to cosine hyperbole of x. Or in this case, you can just use cosine h or cosine hyperbole of 0.783. Dito. Okay, so take note of this one. na properties tsaka ito. Okay, so now, so ito na siya. Ito yung equivalent natin with the use of the, this is in the relations between hyperbolic and trigonometric functions. So for the imaginary, no, we use the hyperbole for this case. And then dito, so the same, we use the trigonometric functions as well. So pwede mo na ma-evaluate, that is cosine of 32.83 and then cosine hyperbole of 0.783. So take note lang na the given rectangular form here, or ito, naka-rectangular form kasi siya, di ba? Ito. So you need to evaluate it in degrees para ma-compute mo siya with the use of cosine function. Okay, then dito, you will use the hyperbolic. Dito sa relations between hyperbolic and trigonometric functions. So results in polar form. So always read the instruction kung ano yung nakalagay sa mga exercises ninyo, no? So if it asks for the polar form, so you need to convert your answer in rectangular form to polar form, like this one. So yung answer mo is in rectangular, then yung hinahanap ni question is, the one who is asking is for the polar form. So this is your answer for the polar form. Okay, ano pa? Arcsine J. So the same lang din to, no? Ito, sa second example. So we use the we identify the positive and negative root. So dalawa yung answer dito. So you have your positive root and negative root. So ito yung final answer mo for positive root, and then ito yung for the negative root. So it depends on problem naman. Because here we still use plus minus. So this is in terms of inverse trigonometric functions. So we use the formula for evaluating this one. So naka-arcsine siya, may equivalent value siya, which is the negative j ln. And then you will apply here your logarithmic properties. Ayan. Okay, actually nandiyan naman. So ln of e raised to j, just transpose na lang, cancel out. So you have your j 0.629. Shortcut lang kita. Arcsine h. I think na correct ko na to because previously may error dito eh. Sa previous module may error to. Pero na-correct na to, na-correct. So this is your answer na. Ito. Ito yung final answer niya. Sine hyperbole. So the same process din. So gumamit pa rin tayo ng hyperbolic functions. Okay, so let's go to our next topic. I hope na na-clarify nyo ang, I hope you ang video natin, ang recorded discussion. Okay, so let's go now to the definition. So this is just the introduction of Laplace transform. I believe, I'm not sure if you already encountered this one. Have you guys encountered Laplace sa circuits 1 ninyo? Sa inyo circuits 1 last sem. The Sir Bildia. Na-encounter nyo na yung Laplace transform. Power series, Fourier series. So if you encounter na yung Laplace transform, I think siguro pro na kayo dito, no? mabilis na lang to. If pag wala pa, then should try to check your circuits notes because Laplace transform no is used, or this is mostly used no sa signals natin. Okay, so it is used in signals commonly found in electric circuits. Then we have also the inverse Laplace. So sort of calculus and integral calculus. So we still use here calculus integration. So we use the integral calculus here in the Laplace transform. And so usually Laplace transform ginagamit na siya used to analyze signals commonly found in electrical circuits, and then it also analyzed in transient circuits. And so titingnan natin. So ano ba yung Laplace transform? Okay, so it is usually defined by a function. Tingnan natin. Laplace and inverse Laplace transform. Pero I think hindi pa na-cover to yung hindi pa na-cover dito yung inverse Laplace. I think this is until lang to until Bessel functions. Yeah. Okay, Laplace transform. So this is the process of transforming a given function. So we have here a complex frequency domain and the time domain. So here we transform a given function from real-time domain papunta sa new function natin, which is in a complex frequency domain. So that is a function of t to a function of s. That is h t to hs. And so here we let h, or the function of t, or that is your time domain, to be the real-time domain or the original function. So ito yung original function mo. So this is, so ito yung Laplace na symbol. So parang siya, nakalambid na L. Laplace transform of a function of t, which is your real-time domain, is just equal to the function of s. Or this is now your function in the complex frequency domain. So in order to evaluate that one, so we can also use the integral function. So that is from 0 to infinity, yung limits natin. And that is the integral of function of time domain times the e. Yung e natin, ito yung Euler. Okay? E raised to negative st. Okay, so this is usually yung e raised to negative st. Ito yung kernel of transformation na tinatawag natin. Okay? Or this is just a Euler raised to negative. Yung s natin is a complex frequency domain, and yung t naman is what we call the time domain. Okay? Of course, this is dt. Integrate this function with respect to to the limits, so that is 0 to infinity. Ayan. So okay, ayan naman pala. So meron tayong definitions diyan. Okay, so let's take a look on the theorems on Laplace transform. So we have 3 theorems. So that is the linearity property. Actually, we have sa ating sa circuits ninyo, you have 2 important singularity functions. Later on, makita na siya sa table of Laplace transform. If you already scanned the you already scanned the notes or module natin. But in circuits, you have 2 important singularity functions na ginagamit, which is the unit step function. Yan. Isa yan, unit step function. Okay, so balik tayo sa So ano yung theorem natin? So according dito, first theorem here, we have the linearity property. So if the function of time and function of time here. So yung ano natin dito, D. Okay, so that is H, T, and I, T are any function whose Laplace transform exists. And A and B are any constants. So this is parang ano lang din to, no? This is just the same as your integration. Okay. So yung constant natin, lalabas lang natin. Okay. So here, yung constant natin is A and B. Ito. So when we integrate, di ba? Constants lalabas natin. And then yung i-evaluate na lang natin is yung function. So here, for the Laplace transform of A multiplied by, or any constant multiplied by the function of time, this is just equal to your constant multiplied by the Laplace transform of the function. Ayan. Okay. Then plus any function then. And then we can evaluate this one using the table of Laplace transform. So, or this is just equivalent to 1 over S. 1 over S lang to. So kung titingnan niyo dito, mamaya no, we will discuss later kung paano ba ito nakuha. Ito. So, Laplace transform of this is a unit step. So equivalent value niya is 1 over S. 1 over S. May cheat naman kayo may code naman kayo. Tawag dito, may codigo naman kayo. So ano lang, familiarize. Okay. Okay, balik tayo sa theorem number 2. So theorem number 2, ito naman yung first shifting theorem. So the transformation of e raised to positive negative dt. So take note of the sign here. Okay. So if e raised to negative bt, then your Laplace transform should be from limits as s approaches to s plus b. Okay. So re-replace lang natin yung function by s plus b. I think mali ito, no? So this is should be negative minus. So edit na lang natin ito mamaya. Ito. So if e raised to negative bt, your s here will be replaced by as s approaches to s plus b. But in this case, pag positive siya, so e raised to positive bt, then yung s mo dito will be approaches to s minus b. Given naman yung b natin dito. Given naman yan. Mamaya tignan na natin sa sa examples. Okay, so yun lang yan. Ito lang yung niya, ito lang yung equivalent yan. That is Laplace transform of function of time, and then as s approaches to s plus b. Hindi mo siya we cannot dito siya maintindihan masyado kung wala sa example later on. Okay, so next we have the second shifting theorem. So second shifting theorem, so basically we have here the general formula, that is Laplace transform of your u multiplied by t minus b multiplied by the f, okay, times t minus b. Okay, so ito lang din siya. So yung proof niya, we can evaluate this theorem using the definition of Laplace transform dito. Okay, so we have here two functions wherein may limits tayo. First we have 0. Okay. 0 to wherein yung t natin is less than b. And then we have for a function of t minus b wherein yung t natin is greater than b. Yeah. So for a function of time domain, or a function of time natin to process Laplace transform, no? So it must is the condition. So, ano yung condition natin? So, these are the conditions. Okay, ito yung condition natin. So, titingnan natin muna. So, with the use of definition of Laplace transform, which is ito, diba? Ito yung definition natin. So, how can we prove that this theorem number 3 is existing? So, here we have the formula. It's the Laplace transform over time domain that is equal to the integral of 0 to infinity. Okay, 0 to infinity tayo, multiplied by, so i-integrate natin yung function of time domain. So this is your integrand, di ba? dt. Ayan. And then, since we have the 2 points here, so separate natin. Or that is from 0 to b, and then from b to infinity. Okay, so we have two limits here, from 0 to b, and then from b to infinity. So the same lang din, hiniwalay lang natin because of the two limits here. Okay, so if we evaluate this one, integral of e raised to s negative st, wherein yung t natin is 0. Okay, ito yung ano natin ito yung value ng ht natin. 0 and f times t minus b. Yan. So if we integrate this one, 0, ito siya. And then for the second, we have here, this is from b to infinity. This is your time. Yung value ng t mo is greater than b, or that is from b to infinity. Diba? So ito lang yung ano niya, representation natin. And then, of course, integral of this one, 0. And for this one, integrate natin to. Okay, so here we use the integration substitution. So we let u as t minus b. Review nyo yung integral calculus nyo. Okay, so that is t minus b. And then, or we can say that yung t natin is equal to u plus b. Transpose lang transpose. Okay, so transpose natin to para makuha natin yung value ng t. Okay, and then you can now have your value. So derivative of u natin, or derivative of t minus b, that is dt. dt na lang natira. And then for the function of u, we have t minus b. Okay, so function nito. Ito siya. Okay, ito derivative of u to So derivative nito. Now we can evaluate, that is integral of 0 to infinity e raised to negative st multiplied by function of u. Okay, so we have now your function of u here. So ano lang, tawag nito, substitution. Diba? Substitute lang natin. So yung t natin, of course, we have here the value of t, that is u plus b. So ito siya. Yung t minus b natin, this is your ito. Review nyo lang integral calculus. Then here, properties of exponent. Okay, so separate natin, that is e raised to negative s times u multiplied by e raised to negative sb. So this is just the same with e raised to negative s quantity u plus b. So with this of properties of exponents. What's next? So we will now have e raised to negative bs. Okay. And integral of 0 to, so the same pa rin. So here we can now evaluate. And so notice that we have here the function of time here, that is ito. So ito yung gusto nating kuhanin, di ba? So prove natin na equal lang yung ito tsaka ito. Or ito, which is the second shifting theorem, is just equal to the Laplace transform of this component or of this term. Okay, so we can now prove that the equation of e raised to bs, negative bs, multiplied by the integral of 0 to infinity, or that is the integral of e raised to su times the function of u du, is just equal to the Laplace transform of the function of this equation. So this is now your theorem number 3, that is the second shifting theorem. So it proves no dito. So some sort of manipulation using the integral calculus. Yan. Wherein yung u natin, itong part na to, ito yung unit step function natin. Okay, so this is your unit step function, or this is also known as the Heaviside unit. Okay, so titingnan niyo yun sa table of Laplace transform natin mamaya. Ayan. So in which it is defined a function that is with limits that is from 1 where t is greater than b, or that is 0 to 1. So this is just integral of 0 to 1. Integral of 0 to 1, wherein yung is t greater than b and t less than b. So 0 to b, then you have your integral of b to infinity. And raised to infinity. Okay. So ito yung Laplace transform niya where s is greater than 0. But okay, we have fourth theorem. So this is a continuous function, no? So this is with the use of derivatives. So the same pa rin. So we have this first order derivative. So review yung differential equations nyo. Your calculus, review nyo. So you have your first order derivative, second order derivative, and third, and so on. No? So ano yung nagagawa dito? So what is happening here? So we just evaluate the first function using the first order derivative, and then saka natin to i-derive ulit. So meaning, ito yung first derivative, ito yung second derivative, and so on. So it depends on the order, kung ilang order of derivative yan. So we will still use this one. So notice that continuous yung function natin and nag-i-expand yung equation natin. Yan, dito. Okay, so let's take a look at theorem number 5 pa. Ito. So this is an exponential order naman and piecewise continuous. So with the combination of integral calculus, no? Yan. So we'll not deal with theorem number 5. Yan, dyan naman yung yung formula. So titingnan natin yung table of Laplace transform. And so unit impulse. So this is delta to delta. Delta t. Delta t. So equivalent function niya, or equivalent, this is in time domain. Okay, this is in time domain. So kung sa circuits pa natin with respect to time, ayan. And then when it comes to frequency domain, of course this is with respect to the frequency. Frequency tayo dito. So equivalent niya is 1. Okay, so this is just a single unit. Okay, single unit. And how about the unit step side? So this is just your u t or mu t. So tingnan natin yung mga examples. Here are some examples. So this was taken sa wait, hindi nyo nakikita, no? So punta tayo sa sa circuits. I will share. Ayan. Ayan, can you guys see? Kita nyo guys?
Yes, sir.
Ayan. So, punta muna tayo sa, sa circuit. Okay. May kinalaman dito si si Laplace eh. Ayan. So, titingnan natin kung tama ba yung table of Laplace transforms natin. Ayan. So, ito yung two important singularity functions na sinasabi ko kanina, which is the unit step function or UT. And so of course we have here your limits, that is for t is greater than 0 and t less than 0. So if your s is greater than 0, then you will have your value of complex frequency domain, that is 1 over s. So paano ba yan? Ito, meron tayong example dito that is situated here. Here we evaluate that Laplace transform of a unit function. So with the use of integral calculus, we can determine or we can evaluate the value of time domain of a Laplace transform of a time domain with the use of the Euler. So we have e raised to negative st. So this is with the use of the definition of Laplace transform. Diba? So ano ganito itong definition of Laplace transform? That is integral Laplace transform of a function of t, or that is your function in time domain, that is equal to equivalent to the integral of this function, or that is integral of ht, or that's your function in time domain, multiplied by e raised to negative st dt. Ito yung definition natin ng Laplace transform, di ba? Of course, we have limits here that is from 0 to infinity. 0 to infinity. So with the use of this one, we can integrate, we can now evaluate that what is the value of ut. Okay, so this is just a unit step, di ba? A unit step lang to. Or that is 1. So now you can now evaluate, therefore we can now evaluate that that is just equal to the integral of 1 e raised to st, that is 0 to infinity. But take note that you have your limits here. So you need to evaluate this function from 0 to infinity. Okay, so if we integrate this one, so integrate natin yung e raised to negative st dt. So this equivalent to negative 1 over s e raised to negative st. Diba? So this is now your value of integral of e raised to negative st dt. And then you apply the limits. That is from 0 to infinity. Or ipa-plus mo lang niya, di ba? That is negative 1 over s e raised to negative st plus e raised to plus 1 minus plus negative 1 over s times e raised to negative st. Or your equation now, or that is equivalent to 1 over s. So siya. So take note lang yung s natin dito should be greater than 0. As based sa ating definition of Laplace transform kanina. Wait. I will just share my whole screen para dito. Ayan. Ito rin siya. Ayan. So take note lang yung s natin should be greater than 0. Okay, so how about the unit impulse? So unit step to How about the unit impulse? So we have here a certain example naman. I will share to you this PDF, yung kay Erwin. So circuits 1 to eh. Dapat na nyo na to na encounter. Na-encounter niyo ba to? Or na-discuss niyo ba to? Pag wala, self-study na lang. And so the same then for the so this is the impulse function, no? So that is the function of your frequency domain that is equal to the integral of 0 to infinity, wherein we have here your time that is from t minus t sub 0. This is just a change of your time. Of course, the same with the use of Laplace definition. Yeah, so here we use the sampling property of delta function. Delta function. Yeah, so ano pala yung gamma function pala, tsaka beta function. So this is now your equivalent Laplace transform of unit impulse, or that is your delta t with this of delta function of t, no? Delta function of time. Yeah. Equivalent to 1. So ang limit natin is 0 to infinity, di ba? So t sub 0 is equal to 0. Then yung e natin raised to negative st. Yung t natin dito is t sub 0. Di ba? So ito. Ito siya. So yung t minus t sub 0, this is just equivalent to e raised to negative t sub 0s. So this is with the use of sampling property of delta function. So review niyo yung circuits 1 ninyo for this case. And this is equivalent to 1. And therefore your Laplace transform of a unit impulse, or that is your delta function time or function t, is equal to 1. Okay, so ito yung complex frequency domain mo. How about the unit ramp? Okay, so here, ito. Yung unit ramp naman, so ito na yung equivalent niya. So paano ba ito nakuha? So we have here examples naman. Basically, ano lang to eh, this is just a parang part lang, mathematical part lang ng circuits sa Laplace. Yan. Ito siya. Ayan, 1 over s squared tayo. So of course, we still use the integral calculus for this case. Then, integration by parts. Balaan nyo naman niya kung ano yung integration by parts. Hindi na tayo magkadtudaan. So, ano talang ipakita ko lang sa inyo how they get this table. Okay. In case na, let's say, malimutan yun eh. Say, may exam, board exam, sa board exam, no? Laplace transform. Di, alangan nga lagpat yung man eh. So, hindi na kinahanglan pag nagpaton. You just need the basic. So, how to get the Laplace transform of t. Yan. So, naalala nyo, with the use of integral calculus and the definition of Laplace transform, that is integral of 0 to infinity, yung limits natin, then yung function mo, that is t, multiplied by the e raised to negative st dt. Then use the integration by parts. Then meron kang u, du, and then yung v mo, and then derivative of your v function. Or your v mo, yung v mo mismo. Ayan. Therefore, your function now in a complex frequency domain is just equal to 1 over s squared. Ayan. So plus mo lang to. Limits. So ang ni siya, no, sa ibang nga book lang. Iba-iba nga ano ilan nagamit eh. So balik tayo sa first part. Ito yun, di ba? So we have here, ito yung sa module natin. But some books, they have Laplace transform of a function, f yeah, in the h, no? Function of time, but still the same. Okay. So instead of h, no, they use the f. So circuits natin, they use s. It's a book, which is also equivalent to this one. This integral of, pag master nyo yung integral, so no need to worry on Laplace transform. Pero pag hindi, review nyo yung integral. So this is just the same. Pinalitan lang yung h ng f. And so still negative st. Halaga padalam ako na sulat dt. Ayan. So pareho lang na pareho lang. Ayan natin. So let's try other forms. So for the polynomials, ayan. I think sa cosine, no, meron tayong example for the cosine. Ito. So circuits 1. Circuits 1 din to ah. Tingnan natin. This is, ito siya. Ayan. Instead of the b, this is the omega unit. Ayan. S over s squared plus b squared. So paano ito nakuha? So, ito yung explanation niya. So, with the use of definition of Laplace transform pa rin. Okay. Then, evaluate mo using the integral calculus. So, integration by parts. Then, apply the limits. Then, simplify your equation. Simplify mo yung equation. So, you have now your equivalent value, that is s over s squared plus omega squared. Yeah. So this is in a cosine function. Yung sa ibang for other equivalent mo sa table, wala na ko sa inyo makita, pero this still applies, no? In evaluating some circuits, transient circuits natin. Okay, so we will go now to, by the way, may questions? Clarifications? Wala? Sure ka mo ah. I posted some additional notes. I think sana yung LMS. Let me just check. Ayan, so this additional readings to. Additional reading material. So this is for the gamma function and beta function, which will be discussed today. And ito yung sa introduction of gamma function. So, basahin nyo na lang mamaya. No? Yan. So the gamma function denoted by this function, of course, the gamma multiplied by k. So this is defined to the integral of 0 to infinity. So this is just integral man gyapon. This is e raised to negative t multiplied by t raised to k minus 1. Okay, yung k mo dito is a certain variable. So this is a certain variable. So take note na lang. Hindi to k na constant ha. So it might be a constant na variable. And, which is convergent for k that is greater than 0. So yung variable mo dito should be greater than 0. Then for the recursion or recurrence formula for this function, magpa plus 1 lang tayo. Or you can just use this either of the three. You can use the gamma of k plus 1, the gamma of multiplied by k, or k factorial. So with the recursion or recurrence formula, you can use either these three. Pareho lang ni sila. Okay, pareho lang sila. For example, we have here, no? In order to prove the following transform, by gamma functions, gamma function definitions. So, ito yung una nating evaluate. Tama ba? So, from its definition, okay, so we have the integral of E dito. So, ginamit na natin itong gamma function dito. Ayan. So, similarly, if we expand this one, that is k minus 1 mo, here we let -1 as s. Okay, so, ito kasi, this is just equivalent to k t k minus s. Pwede rin yan. Diba? Or we can simplify this as st raised to k. Okay, so we let -1 as -s. Then we substitute. We simplify this one. And then from this point, so we use the integration by parts now. Shortcut na lang to, shortcut. Then, take note. So, the Laplace transform of t raised to k with the use of your Laplace transform table is just equal to the integral of e raised to the -st multiplied by this function that is t raised to k. Ito yung function mo, t raised to k. Diba? So, ito, inano lang to, in-expand natin to. The use of properties of exponents dito. Alam niyo na yan. And then, so ano equivalent dito? So this is just the Laplace transform with the definition of that is Laplace transform of say ft. Ft. And this is just equal to, recall natin yung yung definition of Laplace transform. Ito yung formula natin, di ba? It's a function of time, integral of a function of time multiplied by the e raised -st dt. So ito yung ginamit natin dito. Okay. Para may evaluate natin. Or your final equation now would be this one. So this is in the Laplace transform of function natin that is t raised to k. Is the gamma function of k plus 1 over s raised to k plus 1. So derive lang natin tong formula na to. So we derive this one. I think this is a k factorial. You can use k factorial over s raised to k plus 1. K plus 1. So you can use either of the three. So ito, ginamit na natin yung k factorial. Pwede namang gamma k lang. It's up to you kung ano yung gagamitin mo. But either of the three, since this is a recursion formula, you can use it. Okay. So that is for the t raised to -1/2. And so how about dito? T raised to +1/2. So tama ba na okay, tama ba? Okay, so titingnan natin. So for k is equals to -1/2, so isa-substitute lang natin. So you'll just substitute it. Pi, tama. Yung answer niya. So correct. Then ito. So substitute na natin, no? So that is the value of the Laplace transform, yung t raised to -1/2 with the use this equation. Dito, gagamitin na natin to. Okay, if k is -1/2, so substitute mo lang, that is t raised to -1/2. is equal to gamma function of negative 1/2 plus 1 over s raised to negative 1/2 plus 1 dito. And then simplify. So simplify natin, this will become gamma 1/2 over the s raised to 1/2. That is your square root of s dito. And so if we check our answer, that is gamma 1/2 is equals to pi. Ito siya. We substitute the k. So this is the proof of the definition using the recurrence formula. Ito. And then we use this one for the following equation, or for the following transforms by gamma functions definition. So from the derived formula naman, dito, so let's say we still have your k here. So it proved that the gamma 1/2 is equals to square root of pi. Ito manipulation na to eh. Ayan. And for your negative 1/2, this is just square root of pi over s. So sa positive naman niya, paano to nakuha yung 1? So dito tayo sa, ito yung sa 1/2, positive 1/2. We have square root of pi. Ito pala. Wait. Okay, this is Laplace transform. So magkaiba. Ito. So we substitute with the use of our formula. So take note lang sa ating gamma function formula in terms of Laplace transform. So ito. Wait, I will just bala ko malimtan yung manigapon karon. Take note yun na lang ang general formula. Ito. And then ito. Yun lang yung dalawa. Kasi ito equivalent naman to ng Laplace transform. So no need to familiarize with this one. Importante is yung Laplace definition. Kasi ginagamit yan dito sa gamma function. And so titingnan natin yung relations among gamma functions. So we have here 3 relations among gamma functions. So take note of this, yung naka-box formula. Although hindi naman to lalabas sa exercises ninyo. Familiarize lang. For the beta function naman, this is defined by these parameters. Integral pa rin, integral calculus pa rin. So take note lang that your m here is greater than 0 and n is greater than 0 as well. So hindi pwedeng 0. Okay. Should be 1 or greater than 1 or greater than 0. So of course, this is connected with the gamma function according to the relation. And then for the Bessel functions, ito rin. Okay, so let's have a example before we end. 5 minutes. 5 minutes. Ito. Titignan lang muna natin dito. So we have here a given function that is 5 sine 2t minus 6 cosine 2t. Okay, so using your Codigo, open notes naman yung exam. Using your Codigo, meron tayong Laplace transform table here. So kukunin na natin yung equivalent function, tsaka kung ano ba yung equivalent value niya. So with the given Tingnan natin Ano yun? Ayan. So, snip ko muna to. Ayan. Then, punta tayo dun sa table. Ayan. So, ito yung given natin. This is the given. So, you have your sine 5 sine 2t. So, sa 5 sine 2t. So, of course, using the Laplace transform, yung constant, labas natin, di ba? Labas natin. Same as dito. So, yung function mo na lang is sine 2t and cosine 2t. So, saan ba ito nakukuha? Or ano ba complex frequency domain nito? Ito, di ba? For the sine 2t, you have sine dt. Or this is just equivalent to b over s squared plus b squared. Yung b mo is yung value mo dito, which is 2. Diba? Ito. So, ito, ginamitan natin ng equivalent value na sa frequency domain, that is b over s squared plus, diba to? S squared plus b squared. And, or in this case, yung b mo is 2, di ba? So you will have now your 2 over s squared plus 2 squared. Ito siya. Or that is 2 over s squared plus 4. So this is now your equivalent of Laplace transform for s2t. Then for the cosine t naman, you have s over s squared plus 2 squared. So saan ba dito yung cosine 2t? Ito naman siya. Okay, yung b mo is just the same, yung 2. Then lagay mo lang siya dito. Oops. Ayan. So yung equivalent Laplace transform of cosine 2t is just s over s squared plus 4. So therefore, your value now would be 5 times the Laplace transform of this term, 2 over s squared plus 4, minus 6, yung constant mo. Don't forget your constant. Okay? So ito yung palaging nakakalimutan. Don't forget your constant, minus 6 times s over s squared plus 4. Then simplify your equation. So multiply, then divide. So the same denominator, so copy lang. This is just 10 over s squared plus 4 minus 6s over s squared plus 4, or you can just have 10 minus 6s quantity over s squared plus 4. So this is now your equivalent of the Laplace transform time domain in a complex frequency domain. Questions? Grabe sila yan, wala sila yung question niya. Ako na lang mamangkot For the second example, so the same lang din. So don't forget your trigonometric identities for this case. Here we use the double angle identity. Dito. Ito. Trigonometric identities. Then here we apply theorem 1 dito. Dito naman, so we use the Laplace transform definition for this case. Yun yung sa example natin kanina on how to prove the definition of Laplace transform. Then we apply the integral, no? Integration by parts dito. So substitution. Then apply the integration by parts, then yung limits. Ano pa ba? So ito by theorem number 2 naman. So first shifting theorem. Okay, so we can discuss these remaining examples by next meeting. So for the meantime, try to solve your exercises. Hindi pa nalabas. Given yet? Kailan ba to? April 5. April 5. Okay. So I will just give it to you in advance para may long weekend ka mo. Okay. So sa Tuesday we will review the example. Okay. And so already posted. Okay, already posted in yung self-evaluation exercise for this module. Okay, wala questions? Sure ka mo? So no need to memorize no need to memorize your table of Laplace transform. Familiarize nyo lang. Okay. Or lagpato nyo lang ang definition of Laplace transform. Then you can formulate to solve this complex frequency domain. Equivalent niya in terms of the time domain. Ayan. Pero kung gusto nyo lagpaton, lagpaton nyo eh. Pwede man lagpaton na. Pero open notes man ka mo mag-exam. Okay, so that's it. Stop sharing, stop recording.